All right, so we were going to try to show here that when a raindrop falls through a layer of uniformly dry air, that the radius decreases at a constant rate. Try to prove that. It's really cool that we can do that. So we just reasoned that because all of the molecules that are lost through evaporation have to be lost from the surface, that the rate of evaporation, which is really, what is that? The rate of evaporation is really V dot, right? The rate of change of volume, because we're losing water to evaporation, must be proportional to surface area, which is 4 pi r squared. So that gives us the proportionality equation, V dot equals K, the constant of proportionality, times 4 pi r squared. Okay, so we get one equation that relates V dot to R, right? Well, we can also just take the volume of a sphere, right? V equals 4/3 pi r cubed, and implicitly differentiate with respect to t. And that gives us, we bring the 3 down, right? V dot on the left side. On the right side, we bring the 3 down, which cancels the 3 in the denominator. We get 4 pi r squared r dot. Well, look, now we've got two equations that relate V dot to R, right? So we should be able to set those equal to each other. If V dot equals the blue expression and it equals the magenta, is that magenta? Magenta expression, then we should be able to set those equal to each other and solve for anything we want to. Okay, so what happens when we do that? If we set those guys equal to each other, if we get K 4 pi r squared equals 4 pi r squared r dot, well, look what happens. The 4 pi r squared cancels algebraically from both sides, and we get the outcome that r dot equals K. Well, what's K? The constant of proportionality. And if the equation up here, actually, let's even do this. Let's say if K is positive, then that would have to be a negative K, right? Because the rate of change of volume is negative. Does that make sense? We're losing volume at a rate proportional to surface area. So if K is some positive constant, then negative K is the constant of proportionality. Make sense? Well, look what we just proved. R dot equals a negative constant. Isn't that what we wanted to prove? We wanted to prove that the radius of the raindrop decreases at a constant rate. Well, that's exactly what that says. The rate of change of radius is a negative constant. That's pretty cool, don't you think? I do. I think that's pretty cool that we can prove that just from this one very reasonable assumption, right? That all the water evaporates from the surface, okay? All right, let's look at something a little more concrete. So what about something like this? A piston is seated at the top of a cylinder chamber. So here's our piston, here's the chamber, with a radius 2 centimeters. When it starts moving into the chamber at a constant speed of 7 centimeters per second, what is the rate of change of volume of the cylinder when the piston is 17 centimeters from the base of the chamber? Everybody see what's going on? So the piston is going to start to move downward into this chamber at a constant speed of 7 centimeters per second. When it's 17 centimeters from the bottom of the cylinder, what's the rate of change of volume? Okay? So we have a nice pretty picture there. What do we need? What are our variables? Suggestions?
S dot is 7.
What's S? What's that?
Speed.
Speed. Okay, so where would how would I, what you're calling S dot, okay, is 7. So what's S? What would S show up as on this? Because I need to label that variable then, right? The variable that's whose rate of change is 7.
So then seven would be d dot, distance.
Okay, so then distance from the bottom is what we're saying, right? Okay, I'm going to call that y. I'm just going to call it y, so it's a more traditional variable. So y goes from where to where in my picture then? It's what distance? There to there, right? Everybody agree? So this distance from there down to there we'll call y, right? Call that the height of the cylinder measured from the height of the piston measured from the bottom of the cylinder. Okay? So what is 7 then? Okay, I think that's close to the right answer, but not quite. Who wants to fix that? Yeah, it'd be negative. How come?
It's the distance going from the bottom is getting closer. The distance is getting smaller.
Yeah, right. Everybody agree? That quantity is decreasing, right? So y dot is -7. Okay, give me thumbs on that. Does that make sense? The quantity is getting smaller. It's a negative rate of change. Do we know any other frame values here for that one frame in the movie that we're interested in? Okay, now is that a variable? That's not. Now, that's a number that's included in our picture, but we want to include it as a number and not a symbol though, because it's a constant, right? We only want to include variables as symbols. But there's one other value that we haven't included in our list that we're given. What is it? What defines the frame in our video? What is 17? Okay, so what do we call that? Y, yeah, that's what we defined as Y, isn't it? So our snapshot is the frame in our video is the frame when Y equals 17. And what are we trying to find? Say it again. V dot, yeah. Okay, so there's all our frame values. So now what do we need to do? Yeah, we need a parent equation. So what variables does it need to relate? V and Y, yeah. And what do we got here? It looks like, what do you think our volume is going to come from? Cylinder, right? Right circular cylinder. It's this cylinder, this yellow cylinder of air or just vacuum or whatever it is, right? It's the volume occupied by the cylinder, right? What this is literally is the cylinder. Okay. So what is the volume of a right circular cylinder of radius r and height h? You guys can figure this one out. Say it again. Yeah, right? Pi r squared h. Has to be that, right? Because to create that volume, aren't we taking a circular area and moving it perpendicularly a distance h? Right? That makes sense? You're just multiplying the area times the height to create the volume there, okay? So it's just pi r squared h. Now for us, we can be a little more specific here. What is that for us? V equals, h is y, right? Our height is y. And what's our radius? 2, okay. So pi times 2 squared. So that's just going to be 4 pi y, isn't it? Everybody agree? Okay, so then what do I do? Yeah, with respect to time. What's that give us? Okay, what are the math gods telling us here? Does the rate of change of volume depend on y at all? It doesn't, does it? Everybody agree? The rate at which volume is changing is the same wherever the piston is. It doesn't matter, right? Okay, it's moving at a constant rate. That kind of makes sense, doesn't it? Then that the volume must be changing at a constant rate, okay? And so all we'd have to do here, if I wanted to calculate V dot, is just plug in chug, and the only thing I'd plug in is a -7, right? So what do we get for our answer then? Y dot is -7. Okay, and what should the units be? Say it again. Centimeters squared per second? Centimeters cubed per second, right? Units of volume would be cubic centimeters, and we're measuring time in seconds. So cubic centimeters per second. Okay, make sense? Okay? We'll come back to that one. We'll come back to that one later. Let's set this one up. Okay, here's another one that's kind of a pretty common one. Yeah. Now I want you guys to do this one, but I want to just help you maybe set this up a little bit, set up the picture. You guys work together through me, and we'll set up a common picture that you can use to solve this one, because this is going to be on your next assignment. Okay. So how would I draw this picture? She's tall.
I was thinking like the pole was like 20, like the pole. I don't know.
Is it floating?
I'll get you started. Okay, there's your street lamp, right? What else do I need in my picture?
A 6-foot tall woman.
I need a woman, yeah, okay, so.
She's a model. She is a model.
Okay, there's the woman. Okay. Okay, we know that distance, right? What other line do I probably need here? Okay, yeah, I need a light ray, don't I? Good. Okay, so. So we need like that one right there, right? Okay. Okay, so let's label some stuff here. Do we know any, we want to write in any constants if they're numbers. What numbers do we know?
Know how tall she is and how tall.
Okay, good. So we know that this distance right here is 5 feet? 6 feet. Okay, and this distance right here is 24 feet. Okay? We're trying to find what here? We're trying to find the rate of change of the length of her shadow and the rate of change of the tip of her shadow, right? Okay, is that a constant or a variable?
She's moving toward.
Okay, so that's going to be, that's not something I want to write as a number on here. That's going to be a frame value of a variable, isn't it? Because her distance from the street light is varying. That's changing. So let's get some variables in here. It tells us some stuff here. They want us, let L be the length of her shadow and X be the woman's distance from the street light. So it gives us a little guidance here. Right, so we'll call this distance is X, and this distance is L. Right? Okay, what do we know? Frame values. Okay, let's get some frame values. Say what would you say it was?
X dot equals 9 and X equals 13.
Okay, everybody scrutinize those and verify them. You agree with that?
Well, X dot's -9.
-9, isn't it? How come negative?
It's just going closer to it.
Okay, because that's a decreasing quantity. She's moving towards the lamp, right? Okay, good. So that should be -9. And our units are going to be in feet and seconds.
13, and then L equals what, 11?
Let's see. What is the rate of change of the length of her shadow when she is 13 feet from the street lamp? So what's 13? X equals 13.
L equals 11, right? No.
And we're looking for which one?
24. Yeah, I didn't do that.
So let's do length of her shadow is what we're finding first. Rate of change of the length. So we're going to call that L dot then, right? Okay, good? Okay. So we need a parent equation.
Good question. 24 squared plus X times L squared equals.
X
The
plus
quantity of
L.
X plus 11.
Get an idea?
Okay.
So you're thinking Pythagorean theorem. So you're looking at this and seeing that there is a right angle right there, right? Okay. Okay, does anybody see a problem with Pythagorean theorem here? Yeah, we don't know anything about the hypotenuse, right? That involves another variable. We don't really want to include another variable. So it's not a Pythagorean theorem relationship. What is it? Is it trig? Okay, so then we got an angle in there, like a theta. Do we have any information about theta here, though?
No.
We really don't want that either, then, do we? Mm-mm. We just need some really, I mean, the relationship just needs to be an equation that involves x's and l's, right? I'll give you a hint. It's really pretty simple. It really is. I mean, you're going to look at this and go, "Oh my God!" It's not like you're thinking of hard stuff. This is pretty simple. You could have come up with this years ago.
Is it 1/2 what X times L plus 24?
So you're looking at like areas.
I don't know.
You got an idea?
This is like turns like a rectangle.
Say it again.
Like a rectangle.
What are you thinking?
Well, just like add X and L together. And that's what we're not looking at the area of it.
24 is the 24.
L minus.
Mm-mm. I'm not telling you. Well, I mean, he's done all this stuff in like half a second because he's done all this stuff before, but You guys will be able to do this one really fast in about a week.
What?
I don't know about,
Are we?
overestimate us.
No, I don't. This is a really, I mean, this is like, you just haven't done one like this yet. But I mean, you're just trying to find some way of relating. I'll give you a hint. It's kind of a, I guess it's kind of a geometry. It's a geometry thing.
Hey, you asked to go back to geometry. Here we are.
It's not, it's nothing, no fancy trig or stuff like that. It's just a simple geometry thing that you would have talked about years ago.
I felt smart a minute ago. But I didn't.
Involves some ratios, I'll tell you that.
It involves ratios.
Mhm.
2x equals I don't know that. It's just a guess. 2L.
She's got very good posture. She stands very vertically.
Oh, it's something to do with 6. 12. 6. X equals L equals L. Well, if you add 24x equals 6L.
What is it? How about that? Some similar triangles. What do you know? Okay, so let's do.
Yeah, I was never gonna get that.
Opposite adjacent, that's from the tangent. No. Like that's just a triangle. Jimmy, you got that. That was all you. Mason, you were kind of right about that.
Okay, look at that. I don't know what that color is. The reddish large triangle and the purple small triangle, are those not similar triangles?
Yeah, they are.
Okay, why? How do we know they're similar triangles?
They got their angles are two angles are. Which
Yeah.
is the third one? Yeah.
Right? Because by angle, 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 right? Which angle, angle is all you need, right? Mhm.
Yeah.
Okay, so they are similar. So now tell me, well, what's a ratio? There's two different ways you could do this, but how would you set this up? What's equal to what? Okay, 24 over x plus L. How about if we flip that and put the variables on top? So large base over large height equals small base over small height. How about that? Okay, so that is, similar triangles is the easiest relationship you'll ever get. It's linear, right? I mean, it's all you got to do is cross multiply to turn that into a simple equation. So you always look for that one if you can. Rarely do you get to use it, but this is an example where you do. What gives it away? I mean, I guess the fact that those are both vertical, right? And they share an angle, right? So you just look for stuff like that when you can. So that ought to get you going then, right? That gives us a parent equation that involves only x's and l's. We ought to be able to do a little calculus with this and come up with a related rates equation pretty easily, right? Now, in the second part of this, they want to know, well, what rate is the tip of her shadow moving? So relative to, like, what would be measuring the tip of the shadow relative to? Well, not, she's moving, right? Relative to the lamp, right? We want to know how fast is, that's really asking how fast is the tip of her shadow moving across the ground, agreed? That's what the second part is asking, okay? So how would I come up with, like, I might have to define maybe another variable for part 2 of this. Right, it's going to be, so we could say something like this. We could say that this whole distance right here, all the way from the lamp post out to the tip of the shadow, what if we call that like S? What is S going to be in terms of X and L? X plus L, right? So what's S dot going to be in terms of X dot and L dot? X dot plus L dot, right? It can be easy. Okay? That's all I'm telling you. Well, that's a lot. We did a lot there. Okay? You got to finish that one. Yep.
You know what the problem is?
Yes.